Hello and welcome to a paper slide lesson with Mr. Hurley. Combination, permutation. Today we're going to answer the questions: what is a combination, what is a permutation, and how can I tell the difference? Let's review vocabulary. Permutations. Permutations are arrangements or lists where the order is significant or important. So order matters in a permutation. Example, the digits 3, 4, and 5 can be arranged in 6 different ways to form telephone exchanges or house numbers. The order is important. There are 6 permutations possible using these 3 digits. Combinations are arrangements or lists where the order is neither important nor significant. So combinations, the order does not matter. Example, if I am adding 3, 4, and 5, the sum is 12. The order in which I write the addends is not important. There is one combination of these 3 digits to make a sum. Continuing with that example, 4 plus 3 plus 5 is 12. 5 plus 4 plus 3 is 12. So it wouldn't matter how I arrange those numbers. It always equals up to that sum of 12. So permutations, order matters, combinations, order is not important. So let's see some examples. Kiera is selling candy bars. She has chocolate bars, raspberry bars, and mint bars. If a customer buys 2 bars and the bars are not the same type, how many different combinations are possible? Is this a permutation question or is this a combination question? Permutation, order matters. Combination, order does not matter. Well, let's examine. So, rise. If I'm identifying keywords and information, I know that there are 3 different types of candy bars. A customer's buying 2 of them and they cannot be the same. So, I'll try one. Guess and check and see what happens. Chocolate bar and raspberry bar. Well, if I choose the raspberry bar first and then the chocolate bar, do I have different candy bars? No, I still have chocolate and raspberry. So in this case it is, if you said combination, you are correct. Now how do I solve? How do I show the work for this? So a combination, one way I like to show my work is through an organized list. So again, the 3 flavors are chocolate, raspberry, or mint. So in an organized list, it's not random. I'm thinking about it. I'm going to start with one flavor of candy bar. So I started with chocolate. So chocolate can then be paired with raspberry, CR, or chocolate can be paired with mint, CM. Then I move on to the next flavor, raspberry. Raspberry can be flavored with chocolate or raspberry flavored with mint. And then start with mint, mint paired with chocolate, mint paired with raspberry. But because this is a combination and order doesn't matter, I have some duplicates or some doubles. Chocolate and raspberry, raspberry and chocolate, the same types of candy bars, so I'm going to cross one out. Chocolate and mint, mint and chocolate, so raspberry and mint, mint and raspberry. So this leaves me with 1, 2, 3. So Kiera has 3 combinations. Try another one. Tony's computer game has a secret 3-digit code. The code has a 7, a 5, and a 3 in it. How many possible numbers could there be with these numbers, with these 3 numbers? So ask yourself, permutation or combination? If you said permutation, you were correct. In this case, a code, the order does matter. If my code to start my game is 753, and I put in 735, I'd be out of luck. So order does matter. So how can I show the work for a permutation? One way to do that is a tree diagram. You can also use the organized list, but this is another way, the tree diagram. I again start with, just choose one of the numbers. I like to go in order so that way I don't forget things. Start with 7. Well, 7 can be paired with 5 and 3 for a 3-number combination. Or it can be reverse the 3 and the 5, or the 5 and the 3. So I have 7, 3, 5. Move on, put the second digit in the first spot. 5, 7, 3, 5, 3, 7. And then the last step, 3 comes first. 3, 5, 7, 3, 7, 5. So there are 1, 2, 3, 4, 5, 6. There are 6 permutations, or 6 different ways that I can have a 3-digit code for the computer game. Now it's time for you to practice. Skylar wants to take some of her toys to her grandmother's house. Skylar has a video game, stuffed animal, and a doll. How many choices does she have if she can pick 2 different items to take to her grandmother's house? So Skylar's going to grandma's house, and she has a video game, stuffed animal, or a doll that she can take. But grandma said, or maybe it was mom, you can only take 2 of those things. So how many different ways can she choose 2 items? So is this permutation or combination? Permutation, order matters. Combination, order does not matter. What do you think? If you chose combination, that would be correct. It doesn't matter which toy or object is chosen first. You know, apple and banana or banana and apple, I still have the same 2 pieces of fruit. So this would be a combination. So go ahead and pause and show your work. And our last practice problem. Marty, Sarah, and Alex had to stand in line for lunch. How many different orders could there be for the 3 kids standing in line? So 3 students standing in line waiting to eat. Hungry, hungry. How many different orders can they be in line? Is this a permutation, or order matters, or a combination, or order does not matter? What do you think? If you said permutation, that would be correct, because the order would be important here. Go ahead and show your work, and good luck.